the stem injection really, so far, is the only way to go. There are disadvantages with it. The imidacloprid itself doesn't like to spread in the tree. And so when you drill holes in the tree and it goes in, it'll go up, but it won't go out. And it'll go up and it'll affect the branches immediately above it, but to the side it won't affect those. And so it's like an uneven distribution in the tree. There's the potential for applying it along the bark of the tree. There's another chemical they've been using in Connecticut, which is not registered in New York, which is shown to be very effective and even in its distribution, but it's not registered here in New York, and I don't think it will be, actually. Probably for good reason, but that's not my specialty. So this is one of the options that we have. Timing is important because you have to do it when the sap is running in the tree going up to the top. But you can only do it a limited number of times. You can only drill into the tree so many times, like maybe two treatments, and you've really compromised drastically the physiology of the tree. Stem spray, as I was mentioning, is low volume. It's probably very safe to use near water as long as you don't get a drenching rain immediately afterwards. And it's uniform distribution, but it's not registered right now, but we might be looking at other chemicals. Who knows? Soil injection, this is the most common use of imidacloprid in the south. And it's very easy to do. You just pour the chemical right around the base of the tree in the soil, and it goes up into the tree. It takes a while to get up into the foliage, but this is the one that they're showing is very effective for a 7-year period of time. Once again, you can't really do this around here near water because the rocky soil gets down into the streams. So host resistance is another aspect. I forgot to mention also, well, I don't know, chemical. I would almost call it chemical. There's a scientist in Vermont right now who's been working on basically a fungal pathogen that is sprayed as an area-wide treatment. He's just going into testing right now. We're not really sure. Hybridization it's like nobody knows anything about resistance. They haven't really identified it. We don't know, but people said, oh, there's this healthy tree in the middle of all these dead trees. If you find something like that, I want to know, because they're actually actively looking at trees that they think might be resistant. And that's a very important way. Silviculture, basically keep your trees healthy, maintain tree health. But don't put on nitrogen fertilizers if you get the Hemlock Wooly Adelgid. That'll just make the Adelgids very, very happy. And other approaches, we have fungal pathogens, as I mentioned, and symbiotic organisms within the gut of the Adelgid. People have been thinking about working on that, but right now it's who knows. So what can we do now? Slow the spread is the word. We need time to develop area-wide treatments, conserve genetic resources. We do that through detection, survey, and treatment. So conserving the genetic resources, the Forest Service and another private company right now are actively engaged in defining genetic diversity of hemlock and collecting seed and preserving it. They're actually looking at starting hemlock groves in Chile where there are no Adelgids, so that they can keep the seeds growing, and because the seed is not very viable for a long period of time. It's a really interesting project. I like that. Detection, that's one of the reasons everyone is here right now. We need to know where it is. It's really important to on an area-wide level to understand the breadth of the infestation and to see how it's developing. Actually it's interesting, there really is no data on the incipient stages of an infestation like this that we have here. This will actually prove to be very valuable information in the general Hemlock Wooly Adelgid research on the East Coast. Okay, so what we do, early detection, identify things, map and prioritize hemlock stands, identify high-value trees, and identify areas of potential exposure to crawlers, campgrounds, urban landscaping, and bird feeders. If you have a bird feeder, don't put it next to your hemlock tree, because the birds, they like to go to the hemlock tree and then they go to the bird feeder and they could be carrying it around. So, what does it look like? This is the first instart. When you get in June and July, this is what you'll be seeing. It's really difficult to detect. That's why in the summertime, forget it. You might find some residual fluffiness, but it's not going to work. This is very low level infestation. You can see there are a couple. here, it's easy to miss this, the very, very low levels of infestation. Here we get a little bit denser infestation. And here we have some imposters, spittlebugs. People know spittlebugs, you know, it sort of like, looks like spit on the twig. That's not an adelgid. Adelgid is white, cottony, waxy mass. Spider egg sacs, you know, they're a little bit bigger and they're not at the base of the needles. They're like, it's like silk. Scale insects and the hairs that they produce sometimes, you know, they're pressed to the needle. The adelgids are on the twig itself, at the base